Hey guys. So today what we're going to be doing is we're going to be covering annuities, and specifically we're going to be talking about the future value of an annuity. We'll be going through what an annuity is and obviously how to do the questions that are required of you in this course. Alright, so let's get into it. So let's just start with what an annuity is, or actually specifically what it isn't. So off the bat, I'm just going to tell you that it's not just compound interest. So you should pretty much never pull out that compound interest formula for any questions that are related to annuities. I'll explain the difference later on, but for now, just keep that in mind. Okay. To put simply, an annuity is just a type of investment. So it's like any other type of investment, like property or shares. It's just a type of investment where you're obviously trying to build wealth. So the key thing about an annuity is you're investing money at regular intervals. So that could be yearly, quarterly, monthly, however many intervals you choose. That is the key. Now, obviously, when you're trying to invest in something, the idea is you want to make more money in the future, and that's basically the gist. Okay? So, lastly, you would know this well by now, the extra money you get at the end is called the interest. Alright, so I want you to imagine that I've started a bank and I'm going to give you some terms for investment. And you happen to be a good saver and you save a bit of cash that you want to make work for you. So here are the terms. I'd like you to invest $1,000 each year. I'm going to give you 5% per annum. I'm going to compound it annually. And I want you to do it for 5 years. And then we'll see how we go. All right, now, how much would you have earned in 5 years? So the key here is recognizing that, once again, I want to remind you, it is not compound interest. So just leave that out of your head for now. Now, have a look at here. If you focus on just this bottom number here, 5,801.92, that is the value of your investment at the end of 5 years. So if you think about it, you've only put in, well, not only, but you put in $5,000 of your own money, and at the end, I'm giving you an extra $800 roughly of interest, which is pretty good. Now, for those of you who have a keen eye, you can actually see that those 5 calculations here, well, these 5 calculations are actually individual compound interest ones. But I don't want you to worry too much about that. The key here is just understanding that the money in 5 years' time is known as the future value. And the little bit on top, $801.92, is your interest. Okay, so I just want to recap what's just happened. You've invested a total of $5,000. At the end of the 5th year, your investment is now worth $5,801. Okay, and this is known as your future value. So very, very important. So it's the value of your investment in the future. Kind of self-explanatory. And that's an extra $800 for doing nothing. So pretty good investment, I'd say. Over time, that would grow super, super exponentially. Is it realistic at 5%? Yeah, I'd say so. All right, now here's a key difference. It's minor, but it's very important to understand. Compound interest is one deposit. So if a question asks for one deposit or one contribution, you use compound interest. If it's more than one, many deposits, you're going to use an annuity, and I'm going to show you what to do by using an annuity table or a future value table. Okay, so let's have a look at some examples. All right, so here you can see we've got a future value table, and this basically simplifies that entire process of, instead of doing individual compound interest calculations, this table does everything for us, literally with one either multiplication or division. So I'll show you how to use it. Now, the key here is to look at the interest rates per period, and these are the number of periods. This says future value of an annuity with a contribution of $1 at the end of each period. Now, the end and start is actually important, but for now, we're just gonna leave it because I want you to be able to actually use a table, which is literally 80% of this topic. Okay, so The question says, use the table to find the future value of an annuity with a contribution of $8,000 per year for 5 years at 3% per annum. So all you need to do is locate 5 years and 3% and make sure that they're in the same units, so years and per annum, so we're sweet there. All right, so we've got 3% per annum, I'll highlight it there, and we've got 5 years, which is there. Now, where do those two numbers intersect? Well, it looks like it's going to be that number there, 5.3091. And all I need to do is I say future value is equal to my contribution, which is $8,000, times this number from the table, which is 5.3091. Okay, so let's just do that now. Let's clear that. 8,000 times 5.3091. So my future value here is 42,472.80. Okay, cool. So in other words, if you invested $8,000 every year for 5 years, at 3%, at the end you would have 42,000 thereabouts. Okay, that's question A. Now I also want to mention one thing. These numbers from now, I'm going to call them the interest factors. Just so we have some language that we kind of talk about. All right, question B. $600 per quarter for 9 months at 8% compounded quarterly. Okay, let me get rid of this for a second. So we've got 9 months at 8% per annum compounded quarterly. So similar to compound interest formula, you need to convert your units. So N, we've got 9 months. And we're doing 8% per annum compounded quarterly. So what do we have to do? Our rate, we need to divide by 4. So that's 2% per quarter. Now, all we need to do is find the numbers in the table or the interest factor and then multiply that by $600. So 9 periods is here at 2%. Where they intersect, looks like that number there, 9.7546. So my future value is 600 times 9.7546. 600 times 9.7546. So my total here is 5852.72. Okay. Now let's just do one more. I'm going to skip C for now. Let's just go straight to D. So $900 per month for 10 months at 12% per annum compounded monthly. Okay, so what's my period? My period is 10 for 10 months. What's my rate? Well, my rate is 12% per annum compounded monthly, so I need to divide that by 12. So that's 1% per month. And now all I got to do is use the table to find my values or my interest factor. So scrolling back up, I need 10 periods and I need 1%. So that looks like that's going to be that number there, 10.4622. So my future value is 900 times 10.4622. So 900 times my interest factor, 9415.98. Okay, pretty straightforward. Okay, let's look at a more applied example. Brianna is saving to go on holidays. She wants $6,000 in 12 months so she can go on a cruise. How much does she invest at the end of each quarter at 6% compounded quarterly to achieve this? All right, so that's what she's investing. That's what she wants, $6,000 in 12 months. And we want to work out how much does she need to contribute. So remember those regular payments that make up an annuity. So she's going in 12 months and it's compounded 6% quarterly. So my N is equal to 12. My rate is 6%, but I need to divide it by 4 because it's quarterly. Okay, so 6 divided by 4 is 1.5%. So I need to find my interest factor, 12, 1.5%. So this is the one. Now, before we were doing multiplying, but now we actually want to work out what the contribution is that's going to get her to a holiday. So times the interest factor. So technically this is what we're doing. Future value equals the contribution times the interest factor. So now we want a future value of $6,000 because she's going in the future, times the contribution, let's just call it C, times 13.0412 is the number in the table. And now it's just simple algebra. So just divide. So our contribution is 6,000 over 13.0412. So she needs to put in $460.08 per quarter to achieve this. Okay? All right, let's go through one more exam style question. So the table below shows future values of annuity contribution of $1 at various periods of time. Now, let me just give you a bit of advice. If they give you a table, you have to use it, okay? So Joe deposits $2,400 into an annuity fund at the end of June and the end of December every year for 4 years. So he's putting $2,400 in end of June, end of December for 4 years. Interest is paid half yearly at the rate of 3.5% per annum. Use the table above to calculate the amount in Joe's annuity fund at the end of 4 years. Okay, so his contribution is $2,400 and it is compounding okay, so we gotta think about this. Every June and December just means half yearly. So how many half years in 4 years? We have times it by 2. So n is equal to 8. Our rate is 3.5% per year, but we need to divide that by 2 because it's half years. So 3.5 divided by 2 is 1.75. So highlighting those 1.75 and 8 periods gives me the interest factor of 8.5075. Okay, so all I need to do is say future value is 2,400 times that number. Times 8.5075. So at the end of 4 years, he should have 20418. 20,418. Okay, so how much interest will Joe earn at the end of 4 years? Well, just think, how much has he put in? He's put in $2,400 every quarter, every 6 months for 4 years. So he's put in 2,400 times 8. So he's only put in 19,200 is what he's put in. And we found from the previous question that it's now worth 20,418. So the interest has to be those two subtracted. So that's 1218 in interest. All right. Okay. Last one. So what single amount would Joe need to invest under compound interest to achieve the same future value at the same interest rate over the same period? Okay, so the key in this question is it actually telling you to use the compound interest formula. Okay, so now you're allowed to go ahead and use this. FV equals PV 1 plus R paraben. And we want to know what single amount he would need to invest to get the same future value. So what we're looking for is PV. So our present value we found in question A, which is 20418, is equal to PV. Okay, 1 plus, the rate is 1.75%. 1.75%. And our period is 8. So we found all of that in question 1. So all we need to do to find PV is move all of this stuff, to use a different color, all of that stuff to the other side by dividing. and just pop it in the calc. So we've got 20418 over 1 plus, so I'll just change the decimal now, 0.0175 to the power of 8. So the present value is 17772.06. So that's our answer there. So he would have to, in order to get $20,418, he would have to invest a whole lump sum of $17,772 to achieve this. All right, so in the next video, we'll talk more about present values of annuities. But for now, I hope this video helped. Let me know if you have any questions below. And as always, the notes will be in the description. I'll see you in the next one. Peace.